lecture. Okay, so integration. So if you have any question, you can interrupt me, okay? You can just ask me any question, but let me just explain to you the basic idea of integration. So roughly speaking, for derivatives, if we give you a function, you will compute the derivative, okay? I think more or less you know how to compute derivatives so far. But integration is something like computing derivative, but we don't compute the derivative, we compute what we call antiderivative. So if I give you a function and you can either compute the derivative or antiderivative. So what is an antiderivative? Is the backward derivative. And so again, welcome, Eugene. So what is the derivative? I think what you learned is the power rule, basically. So today I'm going to show you the antiderivative for the power rules. You can compute them for trig functions, for any function actually. But let me probably start with an example. So you will see what I'm talking about. Again, integrals is the same as antiderivatives. They are the same. Actually, indefinite integral is set of all antiderivatives. So like the backward of derivatives. Let me start with an easy example. Okay, let me define the antiderivatives very briefly. Okay, now if I just give you this function, let me use some colors. This one, x cubed. I think by now you know how to compute the derivative. So the derivative is d over dx of x cubed, which is n x minus 1. That's the power rule. As I said, the power rule is very crucial and very useful, at least in Calc 1. So now for x cubed, n is 3, so you will get 3x 3 minus 1, which is 3x2. That's the derivative. Okay, so x cubed has derivative 3x squared. Let's say sine x has derivative cosine. Tangent derivative, I think you know how to compute derivatives. Now let's go backward. Now, if I give you this function now, this one again, backward, if I give you this one, so now to go backward, you have backward. Sorry, I'm still at this crappy thing. I need to get something more professional. So the backward, now if I ask you the question, which function has derivative x squared? So I think most likely it's not a hard question. So x cubed, the derivative, you go this way by the derivative and backward by what we call antiderivative. So x cubed is called antiderivative of x squared. Okay, so this one is the antiderivative of this one. Okay, like cosine x is antiderivative. Sorry, this cell phone is antiderivative of sine x. As you can, I just just want you to understand that integrals is like the backward. Say, give you a function, you have to look which function has derivative, that function. But let's look to this one. Let's now just deal with 3x squared. If I ask you now, look at this one. So if you take, for instance, x cubed is antiderivative of 3x squared. Okay, if I derive x cubed, I will get 3x squared. Okay, if I derive also x cubed minus 5, same, I will get 3x squared. If I derive x cubed plus 97, I will get 3x squared. So in other words, all of them, all these functions, okay, all these functions, this one, sorry, this one, and this one, all of them, they have derivative 3x squared. Why? Because derivative of a constant is 0. So if you take derivative of 0 or negative 5 or 97, slope is 0. It's a constant. So now, in other words, if you take this one, derivative of this one is 3x squared. If you do the math, is 3x squared plus derivative of c, and derivative of c is 0. Okay, what I'm trying here to explain that there are infinitely many antiderivative for the same function. So if I give you 3x squared, the set of the antiderivatives, there are tons of them. You can take x cubed plus 1, x cubed plus 2, etc., etc. Okay, so there are infinitely many, and that's why we call it indefinite integral. Now you understand why. So this one will be the indefinite integral. And what is an indefinite integral? Is basically set of all antiderivatives. Yes, same. If I give you this function to x, and I ask you, give me the integral of 2x, or one, or just one function that I derive that give me 2x, I think everybody would guess x squared. So if I derive x squared, it's clear is 2x. So x squared is exactly one antiderivative of 2x. I can add again here any constant. You can add 1, 2, 3, because the derivative is still 0. Then this one becomes 2x plus 0. It will still give me 2x. So the family of all antiderivatives is this one. I hope it's clear. Okay, let me switch off this thing. All right. Okay. And of course, if you derive x squared plus c gives you 2x, blah, 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 blah. But now this has to do with another field in math called differential equations. Okay, what is differential equation? Is this one. For instance, you may be asked, find y. All right. So you may be asked to solve this equation. Solve y prime equals 3x. In other words, or y prime is x squared plus 1. And if I ask you which function y, if you derive y, give you 3x, or if you derive y, give you x squared plus 1. So now, if this is called a differential equation, like for this one, for instance, you will have. Let me show you. Let me give you an easy one, actually. This one. Solve y prime is 2. So which function, if you derive as function of x, of course, give you 2. So the answer will be 2x. And actually, if you want what we call the general solution, it will be, this is called general solution. So, okay, is 2x plus a constant. Yeah, this is what we call differential equation. You have to find the function of x such that if you derive, and this function is what we call antiderivatives. See, this one. 2x is the antiderivative of 2. Now, if you add the constant, it gives you the general solution for the differential equation y prime equals 2. So do you guys have any questions so far? I cannot hear you. Oh, cool. Okay, Alejandro. At least someone is reacting. Thank you. I don't know what is happening there. So, but if you have any questions, just let me know. And anyway, I will upload this one on Blackboard so you can take a look. Okay. So at your ease. Okay. Just roughly speaking, I just want. Okay. Okay, Eddie. Hi, Eddie. Okay. And if you want to graph the antiderivatives, they look like this. If you can see here, see 2x. 2x is the one that go by 0, that cross 0. 2x. Now the constant minus 1. 2x minus 1 is this. Actually, it will hit at 1/2. 2x minus 2. 2x minus 2, it will hit 1, etc. So this one will not be in the exam, this kind of question, but it will be most likely in your homework. Very often the exam, they will just ask you to find the antiderivative of 2, or this one, for instance, the function that you derive to get 2. But they may ask you to draw, but you can see they have the same slopes. Okay, let's go now to something more serious. So the differential equations. So if you want to solve this equation, okay, mixing. If you want to solve this equation, this one, the y or y prime, or basically y prime equals some function f of x. Let's say this one, I give you this function f of x, and I ask you find y such that y prime is f of x. Usually, if we use Leibniz notation, y prime, if you remember, is dy over dx. Okay, So now if you multiply by dx both sides, you will get this one. dy is f of x dx. And that's what we call anti-differentiation. Now, if you want y, you just take this notation, basically. This is the notation that we use. I'm not sure if you can see it. So integral of f of x dx. This is called integral. It looks like an S. Okay, it looks like this. So if I give you, let's say, integral of 2 dx with respect to x, this one will becomes 2x. So you have just to look for the function that you derive that gives you 2, and it will be 2x. And of course, you can add any constant. Okay? If I, for instance, give you integral of cosine x dx. Okay. Can someone tell me what is integral of cosine x? In other words, what is one antiderivative of cosine x? Can somebody answer? Excellent, Alejandra. Very good. I'm very happy to, yeah, cool. Eddie, that's correct. Is sin x. I think you understand. So remember, this is really the heart of your exam and final exam is integrals. Like the derivatives for the previous exam, so this one. So you have just to look for a function. Now you are not computing the derivative of cosine. You are looking for a function such that the derivatives, if I derive sine, it gives me cosine. See the backward. All right, cool. So I think you got it. Okay, I am almost done here, but let me just give you some examples. So again, this is the notation that we use. This one that you can see. Integral of the derivative is just, let's say, it is f of x. We use this symbol like sum. Actually, it comes from sum. You will see later on why, maybe next lecture, because we can compute some interesting stuff with these integrals. Okay, and obviously, let me see. Okay. And obviously, the derivative of the integral is f of x. Let's say if you want to derive, if you take integral, 1 minute. It's really, if you take integral of 2 dx, okay, this one, see? If you want to derive this one, it will be derivative of 2x, because this one, integral of this one is 2x, then it will be 2. So you go back just to f, see? Anyway, I think is, let me now give you some examples. Let's start with the constant. So in this side, in left side, they will give you the derivative. In the other side, they will give you antiderivative, for what we call integration. Integral, derivative. For differentiation formula, integration formula. So it looks like derivative of a constant is 0. So now if you integrate 0, it gives you the constant, not too hard. Now if you take derivative of a constant times x is the constant, let's say here k is 2, derivative of 2x is 2, integral of 2 is 2x. Okay, not too hard. Another formula, derivative, if you take the constant, you don't touch them. If you remember, if there is a constant, just leave it there. Like what happened to the constant, it comes out of the integral. You can see that this one comes out. It becomes k. If let's say you have 2 f of x, it will be just 2 times integral of x. And of course, some stay. Derivative of sum is sum of derivatives. And if you have the difference, this is, I think you saw this kind of property for derivatives. So like integral, let me write it down. Yeah, it's hard to use to, but now today I'm gonna just finish with this property, the power, like for powers. This is what I want you, if you remember this from Calc 1, before exam 2, we did the derivative of xn is nxn minus 1. I think everybody agrees. So if I take derivative, say, of x4, it will be 4x cubed. What is the meaning? Remember, the integral is the backward of derivatives. Now, just imagine I asked you integral of x cubed. Just x cubed. I know now that integral of 4x cubed will be x4. Okay, if you take integral of, if 4 is here, is x4. I think I agree with this one. Now, but remember from this property, this 4 comes out, okay? Then I can divide by 4 and divide by 4. So now, what does it mean? It means that okay, that's what you really need to remember. This is about 50% of your grade. This now, if you do it, actually, you can see here 3D, it becomes 4. So the rule is this one. Integral of xn is xn plus 1 over n plus 1. I'm still learning how to use another. I want to use here the whiteboard, but that's okay. Let me just keep it simple. Let me remind you of some interesting integrals. If you remember, derivative of sine is cosine. So now integral of cosine becomes sine. See? Now, derivative of cosine is minus sine. Be careful now. Integral of sine is minus cosine. Now, derivative of tangent is secant squared. Now, integral of secant squared is tangent x. What is derivative of secant? Is secant times tangent. So integral of secant times tangent becomes secant. Derivative of cotangent is minus cosecant squared. Derivative of cosecant squared is minus cotangent. So you just flip them. Okay, so integral is basically the backward of derivatives. Let me give you more examples. Now, just imagine I asked you, what is happening here? Okay, if I ask you integral of 3x, okay, integral of 3x, as you know, the 3 can come outside. Okay, this 3 can come out. It will be in 3 integral of x. Now, which function you derive gives you x? Then you have to use the power rule. X is x to the power 1. Okay, so n is 1. Then the answer will be 1 plus 1 over 1 plus 1, which will be x squared over 2. And you can check by yourself if you derive x squared. This one give me 2x. Okay. Now if I divide by 2, what will I get? I will get x squared over 2 derivative is x. Okay. So integral of x will be x squared over 2. So then the answer, and of course this constant you always add this one. The hard part is this one. This is the hard part. But in this case it's fairly easy. It's not like, so the antiderivative of 3x is 3 over 2x squared plus. Okay, very good. All right, let's just skip this slide. This is just okay. There is something in differential equation called initial conditions and particular solutions. This is very, very useful in engineering mainly, and in some more applied area of mathematics. Sometimes you have differential equation, and and we give you an initial condition. Let me tell you what I mean. We know, for instance, that let me put it so you can see. You have already seen that the equation has many solutions. Okay, of course, let's say if I ask you to do integral of 2 dx, if you remember, is 2x plus c. We always add c. The problem why they say many, because you can always add a constant. But sometimes so this one solution of this integral, there are infinite many. But there is but sometimes when they tell you the initial condition, what does it mean, initial condition? Let's say this one is g of x or f of x. Yeah, let's just call it f of x. But sometimes they tell you f of 0. F of 0 maybe is 1. Okay. But what do you do? Then you have to plug in x to 0. Then you do c has to be 1. Okay, then you will get, actually there is no c. C is let me see if I can find this. I can never find the eraser here. I need to learn about this stuff. Okay, anyway, it's gone. That's what I'm. Okay. Okay, that's situation. Let me give you this example. Let's say now I give you something a little bit more complicated. If I give you this y integral of this, so I want you just to find the function. See if you derive. I think for one is easy. Integral of 1 is just x. Okay, because if I derive x gives me 1. If I give you 3x squared, if I derive x cubed, it gives me 3x squared. So the integral of this becomes this. This is the initial condition. But sometime what? But of course here we add this famous constant. this one, see? This constant, that's why we call it general solution. So if you look here, general solution will look like this. But if you graph them, what happened? If you remember the cubic, they all look like this one. So for C is 0, if you can see this one that hits the x-axis, see this one? Then the other one are just parallel. So actually there is one and what else? And negative one. Let me just delete everything. C1 and negative one are solutions. It looks like this, like this. Okay, sorry. Actually, and this is okay. That's only this one. Now, but sometime we want different ones. So if you take +1, you will jump to this one. You will jump to this one. If you put here +2, you will jump to this one, but they are all parallel. So you have a bunch of solutions. So in physics or in engineering, they want one with the initial solution. So you have to know which one you are talking about. So usually what we do, actually this one solves this differential equation. This is differential equation. Okay. All these ones are the solution for this differential equation, all this curve. There are infinitely many, and that's why we have to do with the integral. So each integral is a solution, but just I can now, if you take the initial condition 4, f of 2 is 4, you will get this one. Actually, where is -3? You will get this one. I think it's in bold. I'm not sure you can see it, but it's in bold. So if you change this one to +1, you will get this one. That's what we call with initial condition. All right. So yeah, but sometimes it doesn't have to be f of 0. It could be f of 2 or f. Now, anyway, you have just to plug in here. If they give you f of 2 is 4, I have this plus it will be 8 minus 2 plus c is 4, blah, 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 blah. 6 plus c is 4. It looks like c is negative 2. Okay. So this is called, again, initial condition. This is general equation, and this is initial condition. And this one will give you, see, will pick one curve. Anyway, they are solving it here, what I just told you. Okay. Okay, let me do this one, and I let you go home. I want you to find the general solution of this equation now, or like just basically solve y prime equals 1 over x squared. Okay. Or which function is there? I give you 1 over x squared. Of course, y will be integral of 1 over x squared. Okay, now how can we deal with this one? And then you have to do the power. Exactly, you do 1 over x squared is x to -2. And what is x to -2? Remember, what is the power rule? The power rule is you do xn plus 1 over n plus 1. So what is n here is -2 plus 1 over -2 plus 1, which is x to -1 over -1. Which is actually, if you do the math, is 1 over x is minus 1 over x. Yeah, because x minus 1 is 1 over x. So you will get this kind of hyperbola. like this. You will get bunch of them is negative 1 over x, but they are assuming x positive. And again, if you add some initial condition, if of 1 is 0, then C has to be 1. Then you will pick just one of them, the one, this bold one. See? Okay, I'm done with this. I just want to make sure I will give you 2 more examples. Hold on. I just want to make sure, please, that you understand this power rule business. I'm gonna lecture again on it. I think section 2. Where is that thing? Yeah, cool. I have it here. Now I know. Okay, let me share this one with you. Okay. Here is the question: is to find integral of this and this and this. Okay. Integral of x, integral of x squared, and integral of 1 over x. Okay. Remember, what is the rule? The rule is xn plus 1 over n plus 1. So for here, n is 1. See? You do then 1 plus 1 is 2 over 1 plus 1. No, n is 2. You will do x 2 plus 1 over 2 plus 1, which is this one. What happens to negative 1? X to negative 1 is 1 over x. If you remember, derivative of ln of x is 1 over x. So x to negative 1 doesn't work. So the power rule, be very careful. Actually, integral of 1 over x ln of x. Yeah, because if you derive ln of x, it gives you 1 over x. So you cannot use the power rule for this one. Lastly, and that's the rule I want you to write down somewhere, but anyway, we'll have this on Blackboard, this recording. Integral of xn, extremely useful. Yeah, this two things. This one I'm gonna circle them again. Integral of xn is xn plus 1 over n plus 1, and integral of 1 over x is ln of x. Yeah, this one actually is better if you. So today, what I want you to remember is this and this. Okay. Okay, like if I give you x55 integral, it will be 55 plus 1 is 56 over 56, for instance, okay? Very easy, n plus 1 over n plus 1. And you can check if you derive this one, it gives you this one. If you derive this c is 0, 50x56, you do n minus 1, which is 56x55, and you divide by 56, gone. Okay? Again, another one before you go. Exponential integral of ex is ex. Why? Because the derivative of ex is just ex. The exponential is the only function whose derivative is itself. All right, let me just check on you if you know. Okay, now let me give you some example. If I give you this 1x cubed plus 1 integral and 5x cubed. X cubed, what you do, you can x cubed is integral of x cubed. What is integral of x cubed? N is 3. 3 plus 1 is 4. It will be x to the power 4 over 4. Plus, what is integral of 1? That's easy. It's just x. Okay, so it will be x4 over 4, this whole thing. x4 over 4 plus x. Again, integral of x cubed is x4 over 4. Integral of 1 is x. 5x cubed, what you do, this 5 go outside. Then it will be 5x cubed, integral x cubed. X cubed, what is it? X to the power 4 over 4 plus a constant. Okay, it's very easy. I think it seems to me that with the homework you will know how to do it. Now you may have something like this. Again, power x squared plus x plus 1. So what do you do? X squared is x cubed over 3. Okay. X is just x squared over 2. And 1 is just x. Sorry, you cannot see x here. And that's the final answer, this one. So you just have to remember the power rule, extremely useful. Again, if you have root of x, you will write it as x to 1/2. I probably leave this one as a homework. I think it's enough for you today. Sometime we combine x, and anyway, that's about it. So for today, I think is all good. Thank you so much. And are you going to have lectures, Alejandra, every day? I think, okay, I will have what I'm thinking, to be honest, I'm thinking to do them, what is today? Wednesday. I can do them on, I'm thinking for your lectures Monday and Wednesday from, but I'm not sure. I need to check with students. I'm thinking I put one at 12, another one at 5, okay? But probably I may add an evening one or weekend one or whatever. So because some students cannot make it at 12 and 5 p.m. on Monday and Wednesday, but I will be here Monday, Wednesday at 12 and 5 for about 1 hour. It's exactly the same lecture. So actually this one is better than the one at 12. Okay, so why I'm not, yeah, but I will upload them on Blackboard. Anyway, if you miss the lecture, you can always go back to go check on your Blackboard. So to answer the question is Monday, Wednesday from 12 to 1 and 5 to 6, and they will send you an email. And they may do night one, probably from 9 to 10 p.m. or sometime when all students are available, actually. How was the exam, by the way? Can anyone tell me? Was it good, hard? I heard some students still complaining that it was too hard. Okay, but anyway, if you, I have to look to the grades and hopefully I see how it goes. I made curve the exam. It was okay now. Oh, okay, okay, okay. I'm happy to hear that because some students were complaining. I missed the practice. Why? Why you missed the practice? Okay, if you miss the practice, I can maybe let you take it again. Yeah, but they told us like the math department We can give you another time to take the thank you. Okay, but just email me, okay? Email me so I can arrange a meeting with you so I can email you again. It will be another random exam, okay? It's not gonna be the same questions, but it will generate random questions, but that's fine. Okay, but I will upload the grades for you, like your lateral grades, and just to give you an idea for some students who actually may think of dropping. So, and if you need extensions for homework, I can give you that. Okay, it's not me, it's the department. Yeah, you know, this didn't come from nowhere. So unfortunately, I'm still learning myself, trying to get some better equipment. So we'll finish being by acting or something. I have too much now going on in this thing. Okay, you have any suggestion for me or question? So before I leave, so everything is good. Okay, again, I will see you on Mondays and Wednesdays from from. Okay, yes, thank you. Okay, cool. Okay. From 12 to 1 and 5 to 6, okay? That's your lecture for this class. And again, if you need any question, you can email me or text me on my cell phone. I can use Blackboard or I can use Zoom. I don't know if you know Zoom. It's very easy. I don't have to use this one. We can even see each other on Zoom. Yeah, I just want. Yeah, unfortunately, I'm not like very comfortable with this online thing, but I'm learning. It's quite new experience for me. But we can use Zoom, and they have office hours, by the way, Tuesday and Thursday from what was that? From 4 to 5 p.m. Tuesday, Thursday, 4 to 5 p.m. and or yeah, my office hours. But I will try to email you. I think next week I will be more comfortable with this online teaching. And again, thank you so much. Okay. Have a good night, Alejandra, Daniel, Eddie, Payon. It seems familiar to me. Eugene, Albert. Okay. Thank you so much. Okay, cool. Thank you, Eugene. Yeah, let me know just how do we leave. Okay, finish.